what does Cambridge really want us to know when it comes to making reasonable estimates? So we're going to solve a lot of past papers. I'm going to do a lot of questions around reasonable estimates. But for now, I'm just going to give you a basic underlying principle of how you can be able to understand this topic of making reasonable estimates. The real deal with making reasonable estimates that I always tell people is, number one, you have to learn to make relations, right? Relate whatever you're given in the question to something that you already know, right? You really need to make relations. Ask yourself, what do I already know? And how does this relate? For example, you might know the diameter of a tennis ball. For example, you would know that the diameter of a golf ball is going to be way smaller, almost half that of a tennis ball, right? They might ask you, what is the diameter of maybe like a golf ball, for example, right? Just a matter of you making relations and saying, this relates to something that I know. How can I then use what I already know to go on and make calculations for something that I don't know? So what some of the tricks that I really highly recommend that you know when you're making reasonable estimates is for you to be able to master the skill of making relations. Another thing that I really want you to consider is what I call the order, the order of magnitudes. Again, guys, this is very important for you to master when you're doing estimates. They might ask you the mass of a car. They're not going to expect you to say 900, 800, 500. They're not going to expect you to say the exact mass, but they give you a range, which is like the order of magnitude. They can say, basically, the magnitude of a car basically is like 10 to the power of 3. 10 to the power of 3 kg. This is like the thousands, right? So it can be 1,000, 2,000, 3,000, 4,000. They might accept it, right? So they usually are very concerned with the powers. So it's very important that you really understand what these powers are, and you can use them to solve different questions. So what are some of the tricks that you can really consider when you're tackling these kind of questions? So I'm going to give you some generic estimates, and then we're going to move on now to very specific things when we get to working past papers, right? So you're going to access my my worked past paper solutions, and you're going to see a lot of different past papers that I've solved so that you can really be able to get a sense of how everything's going to work. But basically, they could ask you, for example, they can say mass of an apple, right? They can say mass of an apple. And knowing an apple, as you can see, right, an apple will have something around 50 to 500 grams. If you've ever bought a kilogram of apples, you'd know that how many apples are contained in there. And then you can be able to really engineer how much a mass of an apple would cost. But look, this is something that you have probably encountered. They expect that you have encountered these things in your day-to-day life, like you've encountered what the mass of an apple is actually going to be like. Or they can say the mass of a human adult. You're expected to know the mass of a human adult. Okay, you can say, as you can see, let's say we have our adult named Sarah. So Sarah might weigh roughly around 50 to 100 kilograms, right? So in adult, you should really know basically how much they weigh. It's about 50 to 100 kilograms. For example, they can ask you for the thickness. They can ask you for the thickness, thickness of a sheet of paper. So if you take a sheet of paper, they're basically asking you how thick, like that thickness. That's what they're asking you. How thick is that sheet of paper? That's very, very small. So how do you calculate it? You might just take a meter rule, right? A trick that you can take, you have your Cambridge exam paper. Maybe you're writing an examination for Cambridge and you have a booklet that you're writing in. So you sort of measure that thickness of that booklet using your ruler, right? Then you measure how thick. It might have like 20, 30 pages or so, right? Then you measure how thick that is. Then you divide by the number of pages that you have. You basically have the thickness of a sheet of paper. Sometimes it lies around 0.05 to 0.15 millimeters. So it's very important for you to be thinking of that. Or they can say mass of a car, right? Mass of a car. You take a car on average, how much is it going to weigh? A car is basically going to be around 1,000 to... A car is basically going to be around 1,000 to 3,000 kilograms at least, right? But there are other things that are going to be very specific that you would not even know, right? For example, the diameter of an atom. So we're just going to discuss those, right? For example, they might ask for the diameter of an atom. These are things that you're just supposed to know as a physics student, right? To make your life a little bit easier, right? It's basically around 10 to the power of negative 10. That's sort of like the magnitude. It can be 1 times 10 to the power of negative 10, but that's basically the magnitude that you'd be expected to know, and associated with the diameter of an atom. If you zoom in, we get to the nucleus. They might ask you, what is the diameter of a nucleus? It's going to be way smaller. So the diameter of a nucleus is going to be way smaller, and it's going to be somewhere around, I don't know, it's something like 1 times 10 to the power of negative 15 meters, right? So it's going to be way, way smaller than the diameter of an atom, right? So those are some of the comparative things that you'll be talking about. And we can also have things like, you have a human head, and then they can ask the diameter of a human hair. You're not necessarily going to guess that. So those are things that you should just know, right? Of a human hair. Okay. That might be something like, 5 times 10 to the power of negative 4. But remember, emphasis is on the order of magnitude, which is this 10 times 10 to the power of negative 4. That is what I really emphasize. Focus on mastering the magnitude, right? That is what's going to get you that mark. Or they could say power of a light bulb, right? They could say, what is the power of a light bulb? And you have seen a light bulb. They expect that you have, when you're like measuring a light bulb, you have looked at least at how much power is going to dissipate. Something around 60 watts. If you've looked at the board of a light bulb, those are some of the things that they expect you to know as a physics student, so that you can be able to really solve some of the problems that come. Or they could say the density. Okay, they could say the density of sound in air, which is something around 0.5 to about 1.5. Or they could say the density of water, something that you should also know. It's 1,000 kilograms per cubic meter. Or they can base their calculations off of that, right? So they can just base their calculations off of you knowing the density of water. They can ask you the mass of a certain volume of water. So it's just basic things that you're expected to know as a physics student, so that you can be able to really solve some of these questions that will be asked. Some of these things might be even the speed, okay, the speed of sound, right? The speed of sound in water, right? Those are the things that they expect you to know, like about 1,500 meters per second. The speed of sound in air, something around 330 meters per second. They also expect you to know wavelengths of electromagnetic waves. But remember, don't worry, if you haven't figured that out yet, we'll reach that topic when we'll be discussing waves. So, but they basically have a rough idea of what are some of the estimates that they might be able to ask you. They can say, what is the age of the universe, for example, 5 times 10 to the power of 17 years. So there are a lot of things that they can really ask you for. But don't really worry. I'm going to solve a lot of past papers, and you're going to be able to see the different examination techniques that you can use to tackle these questions. But I highly recommend, guys, the best way to get good at making estimates, like I've said, be exposed to a lot of things. Relations, be good at making relations. Number 2, pay particular attention to the order of magnitude. And number 3, the last tip, do lots and lots of question papers so that you can really be able to understand. I'm going to try to solve a bit of them, but I won't solve all of them, right? There are a lot of papers, but I'm going to try to solve as many as I can. But I recommend on your own, some of that I've solved, go ahead and also look for other of them and create sort of a booklet, right? I highly recommend that you create your own notes, whereby you'll be listing every single quantity you come across, right? Even in your daily life, you just be like, I want to talk of mass of an orange, right? You just like, you write it down in your book, right? Or you have a book where you were collecting past papers, and you just be putting things from past papers in that book, where you like the age of the universe, let me put it that time for, and then when typical volume in cubic centimeters of a human head, I showed that in one past paper, something around 1,800 to 2,500 cubic centimeters. That's not something that you can really come up with, but like if you have been exposed to similar past papers, you can be able to sort of solve these questions. So highly recommend, guys, really do a lot of questions, and you can really be able to solve estimates when they come. They come like 1 mark or 2, but it's very important for you to capitalize on every mark that comes in your exams. Okay. And in the next video, I'm going to be talking about how we can express derived quantities as products and quotients of SI units. And I'm also going to be talking a little bit about homogeneity of physical equations. So it's very important for you to have a rough idea of where we're going with this concept. So thank you guys for watching, and I'll see you in the next one.